I'm really excited to be here, do a little bit of Python, use a little bit of VS Code. I'm going to be using also Copilot, but what's the idea here today? It's we are going to be using like a real world use case for building a data set. So I'll explain a little bit of what's going on here. There is this bike trail for mountain biking, and they announce what trails are open and what trails are closed. And as you can see here, what I have right now is all of the statuses. So I've scraped all of the statuses for this community-run website that exposes all of these statuses. So what we're going to do here is we're going to, from this raw data, we're going to try to take away some of these things and analyze them and create a data set. Now, in data engineering, you might, if you've been trying out some popular data sets like the Titanic or the Boston housing market and data sets like that, everything is pristine, everything's ready to go, everything is good and ready. And but that's not real, right? But when you're going into a professional situation, what happens is that you're faced with a situation like this. All of these messages that we're seeing here are not normalized, right? So let me make this a little bit bigger. Let's go and analyze. First step is we need to analyze. We need to figure out what we're working with, and then we'll go into kind of like the constraints of what we're building. So effectively, these are status messages. It's one per line, and it's one of various different situations. One is either all the trails are open, or all the trails are closed. That's another one. Or we're dealing with two specific mountain biking trails. One is Blankets Creek, and the other one is Rope Mill. So it might say, hey, Blankets Creek is open. So you can see here, let's find this one. Blankets Creek is open, but Rope Mill remains closed. Now, there's different ways that we can look at this data and try to construct our data set, right? So the idea is like, let's imagine a business scenario where we're getting, hey, a manager comes in and says like, we have this raw data, we need to make sense out of it so that we can, I don't know, perhaps make a machine learning model, or we can do a little bit of data science. But let's just imagine that is something related to either machine learning or data science itself, and we are going to have to, our task today is to build a data set. And we need to do it very quickly. We only have 20 minutes. So let's go ahead and do that. I'm going to use a little bit of Python, and we're going to try to go super fast here. So I have this generate.py. And in this file, I have a little bit of instructions here so that they can guide me through. We're going to perform several steps. At the end, what we're going to have is a CSV file. So we're going to start by understanding what the constraint is. And here we're going to create a CSV data set with 3 columns. That's perfect. What's the status? One is Blankets Creek and the other Rope Mill. We're going to use a 1 for open and a 0 for closed. Let's go ahead and read the status.text and remove some duplicates. So if we go and take a look at status.text, you can see that this scraped data has some of these statuses are repeated. We don't need to parse every single one. And we have about 727 statuses that we've captured here with this raw data. So first task, we need to try to get these to be lower. So statuses, we're going to, first thing we need to do is like, how about we need to open these, and that looks fine. So what we're doing there is we're opening status.text, and we're going to read. That's what the R stands for. I'm going to assign it the F variable. And we are going to go ahead and loop for line in file that read lines. So we're going to read every single line. And it's actually not file. This is going to be F that read lines. And what we're going to do is we're going to make statuses a set. So by using a set here, we're going to remove the duplicates, right? So we're going to say that, and we're going to do line, we're going to do initial count. We're going to plus equal 1 that. So every time we go through each line, we're going to count just to see how many we're getting rid of. And then we're going to say statuses that add line. We're not going to strip yet, but I'll show you why in a second. And then here we're going to print some of the things that we want to take care here. So initial count, we're going to do that. And initial count is how many we have. For what we're reading, if we're getting rid of any duplicates. And then we're going to take a look at the unique statuses. Perfect. So I'm going to run this and let's see what we have. So remember, we're starting from 720 or something. All right. So we have initial count 727, and now we drop to 434. Okay. So we're making progress here because we've reduced the number of lines we're processing. So remember, we need to go very fast as one of the constraints. We need to do this in like 20 minutes. And we need to construct this data set. So we've gotten rid of like a lot, like close to, I would say, like 35%, 40%. So we dropped that, and that's important because we don't want to deal with duplicates. We want to do the work once. We don't want to do it many times. All right. So next, now we know that we've removed duplicates, but there's some other things that we can do. Let's take a look at status.text again. I'm going to scroll very fast all the way to the top. Now, sometimes this data set is using uppercase, like here, but sometimes it isn't. So we can actually normalize this. And in machine learning, sometimes when processing for natural language tasks, they do some normalization of text. We don't need to have a difference if blankets creek is misspelled with or camel cased or everything's lowercase. So let's get rid of that casing. And the way we can do this is by making everything lowercase. So let's go ahead and make this lowercase. So I'm going to create a function to make things easier. And I'm going to say normalize. And the normalize function is going to take one line. And we are going to reassign line. I'm going to say line equals line that lower, right? So line equals line that lower. And then I'm going to return the line. Just for now, just going to make everything lowercase. And then this function here called normalize, I'm going to reuse it here in this loop, and I'm going to say line equals normalize line. So I'm sending the line over to the normalize function. That normalize function returns my line back, and I'm going to append it. So let's see if that caused any differences. I'm going to run these. We got rid of quite a few there, like almost like 60. So now we went from 727 to 374. All right, we're making even more progress. Let's continue making our normalization case here. And this is almost like brute forcing. We're throwing everything we got at this using almost no structure. It's just a single file. This is very top to bottom scripting, and we're just trying our best to accomplish this task. All right, so we've done our line that lower. Now let's add a couple of extra things to this function. Of course, we could make it prettier and we could add more functions and do more things here, but let's try to go a little bit fast and not worry so much about how robust and well, it is robust, but not so clean, right? Not so we can make it professional later. All right. The other thing that we can do is we can use strip. And what does a strip does is it removes the white spaces, the training white spaces. So if some of these statuses were captured incorrectly when we were scraping data, then this is going to make it a little bit better. So there we go. We reduced even further, like another 30 went away. So we're making even more progress. The other thing that we can do, it is we can, if we take a look at status, you can see that some of them will have non-alphanumerical characters like exclamation signs. We don't need commas. We don't need full stops. So let's get rid of those. So effectively, by taking all of these unique aspects of these phrases that are almost similar, we are going to make it easier to process. So let's keep going. I think here we can do something like, we're going to join, and I'm going to explain exactly what this is happening here. So we're going to do eye for eye. We're going to do a comprehension here. And this is kind of like, you could do this in a loop, but this is a case where we can actually run this and make it go in one line. So we're going to say for eye for eye in line, if I is alnum. And what that function does, what that call does in the string, so I'm looping over every single character in that string, and I'm saying, hey, if you're an alphanumerical character, yes, I want you. However, I don't want to get rid of white space. So I'm going to say, or I is space. So perfect. So what is this doing? It is going to remove all of the exclamation signs, the dots, the semicolons, the commas, all of that stuff is just going to go away. And we're going to reassign that to line over here. And again, we're going to return it. So let's just go ahead, save that, run it again. We got rid of quite a few. See that we went from 356 to 322. Okay, perfect. So we're still making progress, but we're almost there. You know, one thing that we could do, because we're processing all of this, is that we can let's go ahead and print. Do a quick one-off. I'm going to say print line, and now where I run this is going to go and do lots and lots of printing here. So let's just quickly check out. Let's check our progress. Not only the count, but let's see what we're working with here. So you can see that everything is lowercase, so that's perfect. And then we're no longer seeing exclamation signs. We're no longer seeing non-alphanumerical characters, which is pretty good. And this, I think, looks pretty useful. And what we're going to do next is that now that I think we're in a pretty good state here, where we've been able to normalize everything. We can try to infer, make a kind of like guess that if certain things are present, then it probably means something that we know. So I'll give you an example. So here, where all trails are open, it is safe to assume that if the phrase says all trails are open, then we can say, well, both Blankets Creek and Rope Mill are open, and we can start crafting what our data set is going to look like. Similarly, if we see something like, say, for example, this is not a good one. We're not going to be able to process all of them, by the way. Some of them we're going to miss, but we're going to be able to capture them and do a very good job at having like an initial good starting point. So not all, but this one's a very good one. So Blankets Creek is open, and Rope Mill are open. So okay, so if we see something like Blankets Creek is open, then we can assume that one's very good, and we can process that one. So how we're going to do that? We are going to start capturing that in values over here. So in values, we're going to start appending number one, the status. next if Blankets Creek is open and the other one is Rope Mill. We're going to do this in a very crude, very brute force kind of way. We're going to check with several if and elif conditions. This is fine for now because we're doing quick development and we want to try to do this very well. So I'm going to remove this print line, right? I'm not going to do that. And the reason we saw a bunch of duplicates, by the way, is because I was printing every single thing. Now, I wasn't looping over the set. Do you see this set over here? The set enforces in Python that everything stays unique. So if I add 100 lines that are the same, at the end of the day, the set is going to have just one. If they're all the same, they'll only have one. So it's not going to let you add duplicates. Pretty cool feature that we get for free. We don't need to check anything. All right, so now I'm going to continue here and I'm going to loop. Do you see Copilot, how is it suggesting things that are useful that are actually the things that I want to do? Yes, I want to loop over all of the statuses. And do you see that it's kind of close to what I want? I want to have the status, and then I want to have two numbers, 0 for closed and 1 for open. So I'm going to say, if trails are open in status, I am going to do values append, and I'm going to say, yes, the status. And I'm going to assume, I think this is a pretty good assumption. I'm going to say, hey, if it says trails are open, I'm going to assume that both Blankets Creek and Rope Mill are open. So I'm going to save that. And then I'm going to leave it at that. And then here at the very bottom, I'm going to create the CSV, because so far what we've done is all of the normalization, all of the work, we've normalized, we've stripped, removed the white space, the non-alphanumerical characters. And now I'm going to create a data set, but for creating the data set, I'm not going to use pandas or any libraries. I'm just going to use straight Python. So what I'm going to do is that with open status.csv, and I'm going to use a W for writing. I'm no longer reading. As F is like I'm assigning that open file to the F variable. And this looks pretty good. So let me explain what happened here. So I'm opening status.csv. This is pretty good. And what we have here is a writer. This is required by the library, the CSV library. I haven't imported the CSV library yet, so I need to do that. And then remember the rows. I'm going to name these columns rather, status, then Blankets Creek, and then Rope Mill. So for each one of these, I'm going to assign a number like I'm doing here. So you can see number one, that means it's open, and then the status. And then I'm going to write all of the values. So that looks pretty good. Let's see what we get if we run this. I'm going to run this. Yes, I forgot to import the CSV module. So let me go and do it nicely here at the top. I'm going to say import CSV. I'm going to save that. I'm going to run it. Now it runs. But now if I go to the file explorer, you can see that I get a CSV file. So I'm going to open that. And I think that looks okay. Of course, all of the ones that it's processing is going to be 1 and 1. There's actually this feature that we can do to make it look nice. And we can click that. So, okay, so status, let's see. BC trails are open, TRM, BT are closed. Well, that's kind of like a tricky one to figure out. So trails are open except the mill. So that means that probably these two are open. All trails are open. So you can see that now we're getting all of these and working very, very nicely. All right, so this is pretty cool, pretty nice. We can keep going because those are not the only combinations. Let's add a bunch more of if-else conditions. And let's go to generate. And so far we're saying, where are we? Here, if trails are open in status, it means everything's open. And now I'm going to start adding a bunch of elif. I'm going to say we can add here if trails are closed in status, we can say values append status 0, 0, because all of them are closed. Now we can say, we can keep adding a bunch of more of elif conditions. We can say elif, let's say blanket, blankets creek is open. It's another one. Let's in status. That looks correct. So we're going to assign a number 1 because Blankets Creek is open. We're assuming too much, I think, here because Rope Mill might be closed. So in this case, I am going to not accept that one. I'm going to say if Rope Mill is open in status, I'm going to do that. So that means both are open. And here I'm going to say elif rope mill is closed, I'm going to say a 1 or a 0. Okay, so I'm capturing here both. Either both are open or one is open and the other one is closed. I'm going to repeat the same thing for the other one. So the other condition is if rope mill, rope mill is open, right? In status, I think I'm looking now right now what we're getting suggested by Copilot. And that looks pretty good. I'm going to save that. I'm going to run it. It looks like it did its thing. I'm going to close the preview, close this one out, and look at our status. So now we should have a combination of fully open, Blankets Creek are open, and then we're getting some of them trails are closed. So that's a 0 and 0. We should be getting a 0 and 1. So we can see here that in this one, Blankets Creek is closed. So that's why we get a 0 here. And Rope Mill is open, we're getting a 1. And let's see what the number of items that we have here. It's 141 updates that we have. So I think this is a pretty useful way where we've been able to do kind of like analyze our status, not a status. Let me open up the status that text. So all of these different various entries, we saw all of these different things that we were dealing with. Is an unnormalized, crude, raw way of looking at data. And then the business case was, hey, Alfredo, you need to go in, create a data set. We want to have this for processing later. And now with this status CSV here, we're going to be able to produce a nice machine learning process where we can take a look at this and be fairly confident. Now, some of these entries are not quite there, right? Like they're not exactly right, but it's easy to adapt, make some changes, and make some improvements. But then again, we're starting from the very, very bottom, from scratch, from something that is unnormalized and something that can be tricky. So I think it's a very good use case, something where you can see that it's a more real world scenario problem to solve. So I'm very excited to have shown you these. And did you see the Copilot snippets just showing exactly what I needed? I think that's pretty powerful and making it really awesome to go faster and feel, kind of like confident that that's exactly what I'm trying to do, because I know that the names of the columns, kind of like dealing with the rows, I know I want to deal with the CSV module there and make some progress. So hopefully this was useful to you. And yeah, so ready to answer some questions.
Thank you so much, Alfredo. I love that you're saying that this is a real world scenario. I love that you did the bike trails. That really is kind of like injecting your own personality into it because, I mean, data is everywhere. So you might as well learn how to harness it and work with it. So thank you so much for showing that. We do have a few questions in the chat. So first, why would learning how to create a data set from scratch be useful instead of using a pre-made data set?
Yeah, well, the thing is that in most data engineering jobs, you're probably not going to be working with a finely curated data set that has been in existence for a while and nobody touches it, right? Data sets by their nature, they're probably going to be ever evolving and ever changing. And in this case, this came to be from an ask of like, I want to really create a data set, and perhaps I want to create an API that understands these status messages. And how I'm going to do this? Well, I'm going to have to do it from scratch. That is going to be the most common scenario. Hey, you're going to have to deal with raw data. You need to normalize it. You need to clean it up, and you need to figure out a way that you can do it pretty fast. It's usually pretty fast. You know, if you're working in a startup, even faster, because resources are limited and you need to go fast to get a working product out very quickly.
I can appreciate that. Thank you so much. I mean, that absolutely jives with my understanding and my experience with trying to work with real world data sets. And in that same vein, I love Jupyter Notebooks. I know some of our audience may be really interested in Jupyter Notebooks. Why would this scenario not use Jupyter Notebooks to create this data set? And why would it also maybe be a good thing?
Yeah, that's a very good question. It's a very valid. I see notebooks as a fantastic way to explore data and see what we can do, maybe some visualizations. But one thing that is starts getting tricky is you probably are not going to have this be a one-off. Tomorrow you'll have a change be added here, and someone may say, your manager comes in and says, you know what, we don't care about this rope mill creek, Alfredo, you need to make some changes and redeploy the pipeline. And you're like, oh, what pipeline? I have a notebook. Do I just run the notebook? Do I need to press, I load the notebook locally? No, the ideal use case is to have all of these super fully automated, where you probably have something like GitHub Actions or some other CI/CD system where you make some tweaks to your script. It goes to magically deploy somewhere and cleans up all of the data. So I think that's a pretty good use case to try to understand Python scripting, how perhaps even if you want to package these at some point and distribute that, it's going to be easier than to try to figure out how to execute a Jupyter notebook programmatically, which is something that notebooks are not necessarily, they were not created for deploying production code or trying to deploy a pipeline where you want to automate things.
Absolutely. Thank you so much for that context. I think we have time for just one more question. So this looks like a really useful first step, but what are some things a data engineer or data scientist should consider as next steps?
Yeah, well, Olivia, very, very good question. I'm a super fan for automation. I've already kind of hinted a little bit about some of the things that you might be thinking about. It is very common to have business requirements change. And if it's not business requirements, it might be a bug. I'm pretty sure I have an extra comma somewhere in there that is going to make this blow up. And some machine learning engineer is going to be very upset at me. But if that's the case, what are we going to do to solve it? Do I want to really write all of this from scratch, or it lives in my laptop? Hopefully my laptop doesn't die someday. No. The thing that we want is automation, build foundational. It's a foundational core of DevOps, of best practices in software engineering. And what we want is that sweet scenario of yes, I have this extra comma, but if I fix it, I commit, I push, someone says that this looks good, and then the automation is in charge of cleaning up and running automatically. I don't have to remember 30 steps. And I don't have to do it from scratch. And hopefully nobody else needs to read my ugly code and figure it out later when I'm no longer around.
So relatable. Thank you so much, Alfredo. We really appreciate having you here and answering our questions.
Thank you. Thank you so much.